A Chinese chip company that most of the Western tech world has barely heard of just went public in Hong Kong with one explicit goal: build a training GPU that competes in the same tier as Nvidia's H100. Not inference chips, not edge compute. Training, the most demanding, most power-hungry, most capital-intensive category in artificial intelligence silicon. The category Nvidia has locked down so thoroughly that its data center GPU business carries margins that most hardware companies can only dream of. Before you file this under another Chinese chip story that goes nowhere, notice what is different here. Biren's Hong Kong IPO in January 2026 is a public market capital raise with a named performance target at the hardest possible tier. This is not a government lab demo. It is not a procurement subsidy dressed up as innovation. It is not a vague roadmap slide that disappears into a ministry report. It is a public commitment on a stock exchange to chase the exact tier Nvidia defends hardest, with real capital now attached to that ambition. The chips that train frontier models are the ones that determine who can build the next generation of artificial intelligence. If you control that layer, you set the pace for everyone downstream. That is the tier Biren just stated it is chasing. By the end, you will understand why that IPO matters, what it can actually buy, where Nvidia's lead is structurally durable, and what the next 12 months will reveal about whether this lap closes or opens wider. Because this is not really a story about one Chinese GPU startup going public. It is a story about whether capital alone can buy performance at the frontier, or whether the frontier is protected by something money cannot reach directly. The race is live. The laps, as you are about to see, are not equal. So, what does it actually mean to target H100 class training performance? And why is training the hardest tier in the industry? Think of it this way. Training a frontier artificial intelligence model and running that model after it is built are completely different engineering problems. Training is like pouring the concrete foundation of a skyscraper. Slow, continuous, load-bearing work that takes weeks, sometimes months, running around the clock without stopping. Inference is running the elevator once the building is finished. You need different machines for each task, and the concrete work is vastly harder on the equipment. Training a frontier model requires thousands of chips running in the tight synchronization, sustaining enormous parallel floating point operations continuously for weeks on end, not occasional bursts of compute, sustained, relentless, precision-critical throughput. The H100 is Nvidia's answer to that problem, built on a manufacturing process that Nvidia and TSMC call the 4N node, a customized variant of 4-nanometer class manufacturing. It is the chip the world's leading artificial intelligence labs reach for when they need to build the next generation of a model, not because of brand loyalty, because of what the silicon can actually do at scale. Here is why that tier matters strategically. Whoever controls training controls what models exist. If your country can only run inference on models that someone else trained, you are dependent on another nation's engineering choices at every level. What the model knows, what it refuses to do, what it is optimized for. If you want genuinely sovereign artificial intelligence capability, you need to train your own frontier models. And for that, you need training class silicon. That is the dependency Biren is trying to break. That is why this IPO is aimed specifically at this tier, and not at a more achievable one. Which raises the obvious question: who exactly is Biren and what have they actually built? Biren is a Shanghai-based GPU startup, one of the most credible Chinese challengers in high-end compute silicon. It is not a government research institute with a mandate and a budget line. It is a company that has been building GPU architecture aimed at the high-performance compute market, with engineering talent drawn from across the global semiconductor industry. It's January 2026. Hong Kong IPO is a significant moment, not because it proves the product is ready, but because it represents a deliberate choice to go to public capital markets with a named performance target at the hardest tier. That target is H100 class training performance, and it is essential to be precise about what that means. H100 class training performance is Biren's stated goal. It is the company's explicit public commitment. It is not a demonstrated benchmark. It is not an independently verified result. No third party has published a head-to-head comparison showing Biren's training GPU matching or exceeding the H100's performance in a controlled test. The chip that will make or break this claim has not yet shipped at that tier. What is confirmed is the capital event, the stated ambition, and the direction of travel. The benchmark comes when the hardware ships and someone actually runs it. That distinction matters. It is the difference between a race that has been entered and a race that has been won. Biren is on the track. The finishing time is still unknown. So, what does the IPO actually buy? Here is where the capital question becomes concrete. Semiconductor development at the leading edge is one of the most capital-intensive engineering processes in existence. Every time you want to test a new chip design, what the industry calls a tape-out, the point where your circuit design gets handed to a fab and turned into actual silicon, you are spending tens of millions of dollars per iteration at advanced process nodes. That is not a metaphor. Each spin of the silicon is a massive financial commitment, and the difference between a chip that is competitive and one that falls short is often just another iteration, another test, another round of fixes based on what the silicon actually did versus what the simulation predicted. More capital means more tape-outs. More tape-outs mean faster learning. Faster learning means a better chip, sooner. In a race where every month of delay costs market position, engineering velocity is a genuine competitive variable. The IPO gives Biren the resources to run more test sessions, hire more engineers, compress the development timeline. That is real. That matters. Think of it like a racing team that just landed a major sponsorship. The money buys more time on the test track, more engineers working the problem, faster iteration on the car design. What it does not buy is access to a track that the regulations will not let you use. The engineering improves, the venue is still off limits, and that is precisely where the structural constraint enters. The IPO is meaningful for development velocity. It does not solve the node problem. The node problem is the deeper constraint, and understanding it is the key to reading this race honestly. At the training frontier, performance per watt is not a preference. It is an operating constraint. Data centers have finite power budgets. A chip that delivers a given amount of compute at higher power needs more physical space, more cooling infrastructure, more electricity cost per unit of work done. Multiply that across a cluster of thousands of chips running continuously, and the efficiency gap between process generations compounds into a real economic and operational disadvantage. The H100 runs on a 4 nanometer class process node, and it is worth being clear that 4 nanometer is a process generation name, not a literal measurement of a transistor's width. The naming reflects where that process sits in the manufacturing roadmap, not a feature you could measure with a ruler. What it means in practice is access to a certain density of transistors per unit of chip area, a certain level of power efficiency, a certain set of capabilities that are only available from fabs running the most advanced tooling in the world. That tooling, at the leading edge, depends on extreme ultraviolet lithography machines that only one company in the world manufactures. ASML, based in the Netherlands, is the only source of the most advanced extreme ultraviolet systems. Biren cannot buy its way to those machines through an IPO. Export controls and the structural reality of the supply chain mean that access to leading-edge extreme ultraviolet lithography is not a check you can write. Biren's manufacturing node trails the leading edge. That is the established fact. The specific node number is not confirmed publicly with enough precision to state here, but the directional reality is clear. Biren is not manufacturing on a 4 nanometer class process. That gap means every chip Biren ships starts the performance per watt calculation at a structural disadvantage relative to the H100 and Nvidia's successors. Imagine two runners in the same race, but one is running at altitude C, thinner air, more effort for every stride. The trailing node is the altitude. You can train harder, invest more, hire better coaches, but every lap costs more oxygen. The gap in efficiency is structural, not motivational, and node transitions take years to close, not quarters. Can Biren improve over time by working with domestic fabs and advancing those nodes incrementally? Yes, and that is almost certainly the path. But the question is whether the improvement curve is fast enough to close the gap before Nvidia's next generation moves the ceiling again. History suggests that is a genuinely hard race to run. Every time the trailing competitor closes distance, the leader takes another step forward on the next node. The finish line moves. So, where does the race actually stand? Read the split honestly. On funding and stated intent, the gap narrows. Biren is now a publicly capitalized company with a name target at the hardest tier, accountable to public markets in a way that a government-funded lab never is. That is a different kind of actor. That is a different kind of pressure and a different kind of discipline. IPO capital buys real engineering velocity, real tape-out cycles, real headcount. On that dimension, Biren just bought another lap. On silicon reality, the gap reopens at the transistor. H100 class training performance is a target, not a result. The node gap is structural. Nvidia continues to manufacture on leading-edge nodes at TSMC, with access to tooling Biren cannot replicate on any short timeline. And Nvidia's roadmap does not stand still while Biren catches up. There is also a distinction worth drawing. For China's domestic artificial intelligence build-out, a credible H100 class alternative OS, even one with some performance gap, is strategically meaningful. It reduces dependence on Nvidia's export availability, which has already been constrained. A chip that can train frontier models at 80% of the efficiency of an H100, manufactured domestically, is worth a great deal to a country that cannot reliably access the H100 at all. For global competition with Nvidia's export business, the node gap still matters. These are two different races with two different finish lines, and Biren does not need to win the global race to achieve strategic relevance in the domestic one. The next meaningful data point is not a press release. It is the process node that Biren's next training chip actually ships on. That number, or the honest qualitative description of where it sits relative to the leading edge, will be the most honest answer to everything this race has raised. Watch for it. Here is my honest read. The triumphalist version of this story, that Biren's IPO means China is about to match Nvidia at the training frontier, is not what the evidence supports. H100 class performance is a stated target, not a demonstrated result. The node gap is real and structural. An IPO does not change fab access overnight. The dismissive version, that this is theater, a domestic story with no global relevance, another Chinese chip company that will fade into subsidy dependency, misreads what a public capital raise with a name target at the hardest tier actually signals. This is not a lab demo. Public markets impose accountability that government programs do not. My read is this. Biren just made the training race harder for Nvidia to ignore, without yet making it closer in silicon. Those are not the same thing. Strategic visibility is real progress. It changes how competitors allocate attention, how customers evaluate alternatives, how the ecosystem around Chinese artificial intelligence compute develops. But strategic visibility is not technical parity. The gap between stating an ambition publicly and delivering it in a benchmark is where this race will actually be decided. Capital and ambition have compressed the gap on paper. The transistor layer has not moved in Biren's favor yet. The race is live, but the laps are not equal. Here is what I genuinely want to know from you. Two things are happening simultaneously. The capital gap between Biren and Nvidia is narrowing, and the node gap in silicon is holding. Which one actually determines the outcome of this race? Money and engineering ambition, or the transistor layer underneath? I want your honest read in the comments, and I mean that. Which matters more, and why? Subscribe if you want to follow what Biren's next chip actually ships on, because that process node will be the most honest answer to everything this race just raised. The split clock started the moment that IPO closed. The transistor is still running the race.